Hi. One of my students asked me a question, and I thought, why not make a video of it? Because it's a very good question. Sometimes when you have a building like this, you have a combined load for the rafter. Because of the combined load to the rafter, you have two different lengths you got to deal with. And how you're going to adjust this. There are two different ways. One, the sloping beam method. The other one is the horizontal plane method. One is good for give you accurate number on a shear. The other one is give you a better number for bending. So let's go ahead and take a look at this problem. It'll only take about 5 minutes. Say we have a leg up here where I live. It's in northern middle of New Hampshire. We get a lot of snow. The ground snow load is about 80 pounds per square foot. And we have this building. We want to go ahead and design the load for it. Important factor is 1, CE is 1.1, CT is equal 1, CS is equal 1. And look up what I have in the board where this come from ACE. We quickly do the calculation and comes out to 61.6 pounds per square foot. In the dead load of the material, which we've done that many times, is basically the weight of the plywood, shingle, rafter, all that itself. It's going to come out to 14 pounds per square. And we're going to go ahead and analyze these step by step using both methods. Let me erase this. The pitch of your roof is 6 and 12. If I divide that by 6, that becomes 1. If I divide that by 6, that becomes 2. So it's 1, 2, and Pythagorean theorem, this is come out to square root of 5. Remember to learn that in the kindergarten. So now we have the pitch of the roof. I'm going to have the total load right here for sloping beam method going to come out to be 14 pounds because we're going to go ahead and use the sloping method. Now we're going to convert this to this angle, and that's going to be plus 61.6 multiplied by 2 divided by square root of 5. And that is equal 69 pounds per square foot. And since it's about 4 feet uncentered, your turbidity width is 4 feet, and therefore your load is going to come out to 69 times 4, and that is equal 76 pounds per foot. So if I go ahead and take that part right here, and that's what I'm looking at. The vertical component of this, that's vertical, that is 276 pounds per foot. Now if I go ahead and say this is my x-axis, that's my y-axis, perpendicular being a y-axis and parallel being a x-axis, this can convert to those components. So basically I can say go ahead and take that one load right there. It's going to have a perpendicular one right here, and then a horizontal one relative to this. We're going to go ahead and figure those out. So to take a look at this, this is 276 pounds per foot. I want to know what is the perpendicular component of this force. This is a vertical force. That 276 is a vertical. What is the perpendicular component, which is right here? Perpendicular component of it. And what is the horizontal component of it? The horizontal will be parallel. This will be perpendicular. We know this is 1 to square root 5. So basically we're going to turn this 90 degrees, and then we can go ahead and multiply those. If I take 276 times 1 divided by square root of 5, like turn it, that will give me the vertical, that will give me the horizontal component of it, which is equal 123.5 pounds per foot. That's this one right here, 123.5, the parallel. To get the perpendicular, be 276 times 2 divided by, that's 2, square root of 5, which is equal 247 pounds per foot. So that perpendicular force is 247. Redraw this. We're going to have this on a roof, and these are perpendicular to the rafter, and they are 247. I can calculate my reaction here. So we're going to say our shear is equal to WL divided by 2. You know that. W came out to 247. And our L, what is this L? We don't know that. Let's figure this L out. From here to here, horizontally, from here to here, it is 18 feet. But what it is that way? So to find this distance, we're going to have 18 times square root of 5 divided by 2 is equal 20.12. How did I get that? Well, how I did this, this is really easy. You just say 2 corresponds to square root of 5. And what if instead of 2 I had 18? What would I have? So 18 times square root of 5 divided by 2, and that's how I got it. So this distance is 20.12. 20.12. Now, because the force is perpendicular, therefore I have 247 times the length of 20.12 and divide that by 2. Our V comes out 2485 pound. And bending, M is equal, it's going to be 247 times 20.12 squared divided by 8, and your M comes out to 12,473. 12,473 inch/pound. Now we're going to go ahead and use horizontal plane method. First, we're going to find out the total load, which is equal dead load plus snow load, and dead load came out 14. We are 14 times square root of 5 divided by 2. And plus 61.6. And my total load comes out to 77.25 pound per square foot. And then we're going to go ahead and multiply that by 4. That gives us 309 pound per foot. So calculating the shear, shear is equal to VWL divided by 2, 309 times, now our L in this is 18. And divide that by 2 comes out to 2701 pound. M is equal WL squared divided by 8. We have 309 times 18 squared. Divide that by 8, and it gives you 12.5 cube foot. Same thing. Hope this was helpful, and if you do, give it a thumbs up. Have a good day.